Okay, today we're going to learn how the bounds tests work and why are we able to use this to find all of the zeros of a polynomial. What we need to remember is that zeros of a polynomial are values of x that I can plug into the polynomial and make the entire polynomial equal to 0. Okay? And so here I have a polynomial, 2x to the fifth plus plus x to the fourth minus 9x squared plus 4x plus 1. And we want to find out if we want to show that all of the real zeros of this polynomial, real zeros, x-intercepts, lie between -1 and 2. Well, 2 would be an upper bound and -1 would be a lower bound. So let's try the upper bound test. Do the synthetic division with 2 and notice that I got all positives down here. Lower bound test, do the synthetic division with -1. Notice that I'm alternating signs, positive, negative, positive, negative, positive, negative. And all of these have to include the the remainder as well. Okay, so what does this really mean? Let's take a look at what this means. Remember that this 2 over here means that I have a factor of x minus 2. So I can rewrite my polynomial now as h of x equals my factor of x minus 2 times this factor down here, which is 2x to the fourth plus 5x cubed plus 10x squared plus 11x plus 26, and add to that my remainder of 53. If I were to do FOIL on this and add 53 to it, I would exactly get this polynomial. So I haven't really changed my polynomial, I've just written it as a factor. Okay, so the question is, are there any zeros or x-intercepts that are larger than 2? Is 2 an upper bound of all of the zeros? Well, let's try picking a number let's try putting any number that's larger than 2 in for x. If I put a number that's larger than 2 in for x, this is going, any number larger than 2 is going to make this a positive quantity that I'm multiplying here by. Now let's plug in a number that's larger than 2. This will be positive, this will be positive, this will be positive, this will be positive, this will be positive. This whole quantity will also be positive. And to that I'm adding the positive 53. So I have a positive times a positive plus 53 plus positive 53. Okay, a positive times a positive is always positive. Add a positive number to it. This quantity here, as long as x is greater than 2, this quantity, or this entire polynomial now, will always be positive. It can never equal 0. That means that 2 is an appropriate upper bound. Let's try the same thing with the lower bound. H of x equals, this -1 becomes a factor of x minus -1. And I have a factor of 2x to the fourth minus x cubed plus x squared minus 10x plus 14 minus 13. Okay, well, let's think about this. If x is less than -1, if x is less than -1, this will be a negative, and I'm going to be multiplying that. If x is less than -1, the negative number to an even power will be positive. Okay, a negative number to an odd power is negative, but I've got a negative in front. That makes this a positive. This will be positive. The negative here will make this a positive and a positive. This entire quantity will be positive, and to that I'm subtracting off 13. I have a negative times a positive, which is always a negative, and I'm taking from that negative number, whatever it is, I'm subtracting off another 13. This will always be negative. It can also never be equal to 0. Therefore, -1 is an appropriate lower bound of this function. That's why the bounds tests work.